Before a raindrop ever touches the ground, it falls through the sky as a nearly pure sphere of water. If you were to catch these drops in a standard plastic bottle, you'd be siphoning water in its most naturally filtered state. But if you seal that bottle and leave it completely untouched for 30 days, you're initiating a long-term experiment in stagnation. While the water looks identical to the day it fell, its internal composition begins to change the moment it enters the container. Locking rainwater in a plastic bottle for a month triggers a 3-stage invisible breakdown, turning the liquid into a microscopic battleground. This starts with the biology of the atmosphere. As rain falls, it acts as a scrubber, pulling dust, mineral particles, and pollen out of the air. When you seal that pollen-rich water in a bottle and place it in direct sunlight, you provide the final ingredient for a biological reaction. This diagram shows the transition at a microscopic level. Sunlight provides the energy, allowing dormant microbes and algae spores to multiply. Expanding the view, these multiplying cells turn the liquid into a green sludge that gives off a foul odor. Storing the bottle in total darkness prevents the algae bloom, but it only slows down bacterial growth. It does not stop it. Within days, the bottle hosts a thriving, unregulated biological ecosystem. The second stage is chemical. While the rain is falling, it picks up more than dust. It absorbs industrial pollutants. Atmospheric sulfur and nitrogen dissolve into the droplets as they fall through urban or industrial air. Over 30 days, these dissolved elements shift the water's pH levels, making the liquid increasingly acidic. But the storage container itself introduces a secondary chemical threat that develops over time. This diagram illustrates chemical leaching. Sitting for weeks, the plastic wall sheds microscopic compounds into the stagnant liquid. These drifting bonds represent BPA accumulation. Without movement or filtration, these chemicals reach higher concentrations every day. By the end of the month, the water is contaminated by both the industrial air it fell through and the synthetic walls containing it. Despite these changes, the top half of the bottle remains deceptively clear to the naked eye. This macro view shows the physics of sedimentation. Over 30 days, gravity pulls every heavy contaminant and dead microbial cell toward the bottom. This results in a concentrated layer of microscopic dirt and pollutants resting at the base of the bottle. The visual clarity at the surface is an illusion. It simply masks the toxic material that has settled just millimeters below. After 30 days, the initial purity of the rain has been replaced by a mixture of microbes, leached chemicals, and concentrated sediment. Drinking this water directly introduces those pathogens and chemicals into the digestive tract, which can lead to serious stomach infections. If stored rainwater is intended for human consumption, it must undergo a rigorous purification process first. This requires high-grade mechanical filtration or intense boiling to neutralize the bacteria and protozoa that have multiplied during storage. Otherwise, this water is better suited for tasks that don't involve ingestion, such as watering plants or cleaning floors. Rainwater is chemically and biologically reactive. Without immediate use or proper purification, long-term storage in plastic changes the water's profile from a clean resource into a biological hazard.
Welcome back to the channel, explorers. We're diving deep into some mind-blowing facts today. Hit subscribe to support us and get more informative videos. Let's share knowledge and grow the VibeQuest 404 community.